Going to make it be a beginner level, and we're going to avoid designs that would be professional level or something you do in college. This is geared for somebody in high school, so we'll keep the design simple. Okay, so let's get started. I have Eclipse loaded up, and what I'm going to do is create a new project. So I'll call it Tic Tac Toe. And what we need to do is create a class. We're going to create a Tic Tac Toe class. I could check this box down here that would put the main method in there for me, but I'm going to do it manually. Okay, so every program needs to have a main method. Alright, so the entry point of the program is the main method. So let's think about the problem. Let's go design it out before we start coding. What we want to do is make the game Tic-Tac-Toe, and from that game we know that there's these pieces to use. Player 1 and Player 2 Player 1 has the X piece and Player 2 has the O piece, and so Player 1 starts first and then Player 2 next. And you keep playing until you get 3 in a row. So the winner gets 3 in a row. If everybody has filled up their pieces and nobody wins, then that is a draw, and we'll need to handle that case as well. So we need to think about the data structure that we're going to use to represent this tic-tac-toe board. And we can use a two-dimensional array, and that would be 2 rows and 2 columns. So the rows go this way, and the columns go this way. Okay, then when we don't have a piece that's on one of these tiles, then we need to decide how we're going to represent that. Well, what we'll do is we'll use an empty string, and then that way when we get a piece from the board, we can use the dot equals without having to check if it's null first. And our pieces, we're going to keep this simple by just having our pieces be strings as well. And as mentioned, high school is the target audience, or beginning Java. And so in beginning Java or AP Computer Science, you use strings and you use the dot substring method and the dot equals method, and so we're going to stick to those items. Okay, so when we are playing the game, each time we move, when we play with our friends, each time we make a move, we ask ourselves, did I win or did they win? And we do it so quickly we might not actually think about that question, but we just manually scan and check that. So we need to have a program do the same thing. So after each time somebody puts a piece down, there's 2 things we're going to check. One is there a win? That'll be a function. And another one is there a draw? And that'll be a function that we make. Okay, and if neither of those are true, then we continue on to the next player's piece. And we check again, we check these items, the next player goes, check those items, the next player goes, and then there is a win. Okay, and then we print out to the screen that somebody won. So we got the data structure. Let's design the user interface now. So our interface, we're just going to stick to a console. So when we make our console, what we want to do is we want to display the board. And then we want to ask the user to enter, let's say player X, enter your move, and let's give them how they're going to enter it. Let's say row 1 through 3, column 1 through 3. So let's say they entered in 1, 1. That would translate to this location up here, like that. So the way we'll print that out, as soon as they enter it, we're going to go ahead and print out the board again with the piece at that location they entered. And then the next question is going to be for the person who's up next, which is player O. So on the back end, we will convert their coordinates to our array location coordinates. So our array is a 0 indexed array, so we need to convert this over to 0, 0. Okay. All right. So what happens when there's a draw? Let's say that there's a draw at this point. All the pieces, we'll drop down later here, and we'll say all the pieces got filled up, and let's fill all these up. Okay, nobody won. So what we'll print out is it's a draw. Now, if it was a win, we'll say who won. Player X won. Okay. So we got our user interface designed out. Now we can go ahead and start programming it. So let's see. We said we wanted a two-dimensional array. So we say private string board. So a two-dimensional array of strings. And then next we wanted to represent our pieces as strings. So we have the empty piece. And I'm going to use all caps to signify this is a value that cannot change. This is a variable that cannot change because I put final on there. Okay. In Eclipse, I hold down Alt and Control and the down arrow key to copy like that. Okay, and then Control D to delete it. Okay, so you notice I'm using static. So what static means is that the data is going to be shared among all the objects of this tic-tac-toe object. So when we say tic-tac-toe, and we say T equals new tic-tac-toe, this will create an object in memory, and T is our reference variable, so it's pointing to that object that's in memory. And we have the board in there, so we can think of our two-dimensional board is in here. It has its own unique copy. If I make another object here, then we have another object, and it has its own copy of a two-dimensional board. The empty variable is a string, and it's static, so it is shared among these objects here. So if I was to change this to something else like a J, they would both see J because it's shared among it. And the reason why I'm doing that is because I don't have a reason to have these objects have their own copy of it. There's just no reason for that. And so I make it static. All right, so let's dive into making the constructor. So what we need to do is initialize our board. Use string, and we'll say the rows and the columns. So 3 rows, 3 columns. Now we said we wanted the board to be initialized with empty squares on each location. And in Java, when you create your two-dimensional array of an object, in this case it's a string for us, by default all of the locations are going to be null. That's the default values. So we don't want nulls in our design here. So we're going to make a helper function called board init, and we're going to call that right down here. And that's going to initialize our board. And so what we need to do is we need to go to every location. So we'll loop over our two-dimensional array and update each location. All right, let's take a quick second and talk about what I'm doing here. Okay, so conceptually we think about a two-dimensional array like follows. That's how we think about it. Well, in memory it's represented like this. There's my rows. At each location, there is another array. So we have a reference to another array here. These are my columns. Okay, so the name of this here is board. So how do you get the length of a one-dimensional array? You say board.length. Okay, so, and the one-dimensional array here is our rows. Now I want to get to the other one-dimensional array that's in this array location. So to see how many columns there are, so I say board of 0.length, and that gives me the length of my columns. So board of 0 here, .length, it's this one right here. And I said 0. In this program, I could have said any one of those locations because all of the columns are going to be the same size. So I say board of 2.length, that would work. We're not going to, but let's say we did shrink the value of this for some reason down here. Then this would no longer work and we needed to update it to 1. So why not just start at 0, like the smallest one? Okay, then we won't have to worry about stuff like that. So we're just going to do 0. All right, so that's what we're doing. And let's go back to that real quick. So back up a little bit here by having this. So when we first come in here, we're at column 0, row 0, and we're going to look at this here. We'll put an empty space in there. Then we'll increase our column, go here, increase our column, go here. Now we are at the end, and we will increase our row and start at 0 again with the column and go there. And we'll continue to do that until we're done. So let's go back to this, and right in here, we say board of 0, oops, row and column equal empty. Control space to get that auto-completeness. That's what I did there. Okay, so just start with E and sometimes just control space just to speed it up. All right, so now we got our board initialized. Let's make our play method. We'll make that public. Public void play. This will play the game. And then we'll make is game over variable, and we'll start that as false. And we need a scanner to input, to get the user's input. So what we pass into the scanner is going to be our input stream. And in this case, system.in, which is the console, so the data is coming from the console. If we were going to read a file, then it would be this, and we would import that. And that would read from a file, and we'd have to surround it by throws, just in case the file doesn't exist or there's some other error. In our case, though, we are reading from the console. Okay, so we're reading from the console. Next thing we need to do is we want the current piece, which is going to start as X. And then we make our game loop. So while the game is not over, continue to do the following. One thing we want to do is display the board. So let's make a private helper method, display board. And that's going to get called right here, display board. Okay, so in display board, we're just simply looping over the board and printing it out. So let's copy this, and here we'll say system.out.println, and we're going to print out. We're going to print the board out. So first thing we want to do is we want to print out the piece, and then we're going to print out. We're going to print out a space and then a bar. So here we go. We say the piece, which is going to be board row column plus that. Okay, so as we're going along, that's going to print. That's going to print the whatever's here, then a bar, then whatever's here, then a bar, and then whatever's here, and then another bar if we just leave it how it is. So we want to see if it's the last iteration, and if it is, we won't print the bar. So let's check that. So what we're going to do to check that is we'll say if the column equals board of 0.length -1, then that's the end. Otherwise, we'll do this. I'm going to hold down Alt and the up arrow key to do that, and then Control D to delete that. Control Alt down to copy, Control Alt up to move it up, Control D to delete. Okay, so if it's the end, then I'm just going to do that, and I'll do a new line. If it's not the end, I don't want to do a new line, because remember we're staying on the same row here, same row. Okay, when we're done with our row, we want to print this out right here. So let's do that. System.out.println. Okay, let's test it out. So tic tac toe, t equals new tic tac toe, t dot display board. What? It could call private. Yes, you can call private method inside of this main here because it's inside of this class. Interesting technicality, right? So, all right, so there we go. Look at that. Okay, so we also have to do the same thing. If row equals board.length -1, then we'll do that. Otherwise, we'll do this. Okay, so we'll do this. Actually, you only have to, let's move it up here. Get rid of that, get rid of that, get rid of this, get rid of that, do this, do that. Okay, there we go. So we'll run this and voila! Great. So let's add one more dash to that and make it look nice, and run that, and yes, looks good. Okay. All right, so what's next? Well, let's print out this guy right here. So let's say system.out.println, place that in there, put a space there to make it nice, put the actual player's piece in here, which is going to be current piece, and then we're done with that. Okay. And then they're going to import their information in. So say row equals scanner.nextInt. And then remember when they input their 1, it's actually a 0 for us. So we'll subtract 1. Okay, so we got that. What if they put in some bad input? Well, why don't we? Well, let's surround it with a try catch to catch some errors. Because before I do that, I'm going to show what it looks like if you don't do it, and then I'll explain what's going on here. Okay, so what we'll do then is we'll say play. And then we'll run this and let's see what's going to happen. Okay, enter your piece. First off, you notice it goes to the next line, so we're going to want to get rid of that new line. But let's say they entered in this, and uh-oh, mismatch, input mismatch exception. So that's what we're going to catch in our try catch. I'm going to catch that exception. So I have my try catch here. And we'll catch the input mismatch exception. Okay, so I'm going to say Control A, Control Shift F to auto format all my source code. Okay, so we're catching it. Let's say we caught it, and let's print out a message to the user that says something like invalid row and column. Please try it again. Okay, and then we'll come up here. So we got this, and then got that. And then what we want to do next is, let's see, once we get the piece, we need to set the piece on the board. And then after we set the piece, we want to check to see if there's a win and check to see if there's a draw. Otherwise, if none of those, then we'll place that piece. So let's make a set piece helper method. Why don't we make it return a boolean if it was successful? So set piece. Now we get to decide what we want to take in. So we need the row and we need the column and we need the piece that we're going to place. Okay, in here we're gonna say whether or not it was set, if it was a valid location to set it at. So let's make a Boolean variable for that called isValid, and we're just going to return that once we're done. So in here we're going to do our work. Okay, first thing to check, is the row less than 0, or is the column less than 0, or is the row greater than or equal to the board.length, or is the column greater than or equal to the board of 0.length. If any of those are true, we know it's not valid. So we'll just say system.out.println, and we'll say invalid row and column. Please try again. Okay. And then we can have our else if, and we'll say, now we want to check to see if the board is empty. So if it's not empty, row column dot equals empty. Then we'll check to see if it's not empty. Something just interesting. I'm not going to do it, but you know there's only one copy of this for all of our tic-tac-toe objects. So let's go back there and look at that. T equals our tic-tac-toe object. Here's the empty square. It has a certain address in memory. I'm just gonna make a random one, B89. Okay, that's the address of it. and this is referring to it, and any other ones will be referring to it. So I could check the reference on that, which is, I could check the address location instead of doing dot equals, because there's only ever going to be one of them. So if it equals that memory address, it's one I'm thinking about. But I'm not going to do that because it would make the code a little confusing, and there's no benefit to me on that. You won't notice any speed difference. So backing up, yes, that would actually work, which is looks really odd, right? And you notice here there's a error. It says put parentheses in the expression, but yeah, confusing, right? If somebody sees that, they say, oh, they got that one wrong. So we're just not gonna do something weird like that. All right, so let's see. We have the empty. We have the system.out.println, and we have the piece already at that location. Please try again. And then else. If it was a place where we could place it, let's go ahead and place it. Is valid as true at this point. Okay, so we passed. So anyway, that's it. And you can review this. If you have any questions about any of the code, feel free to leave comments asking them. Okay, so we said that we're going to place that piece, and if it was successful, we're going to check to see if there's a win. So set piece, row column, and then our piece, which is going to be the current piece. Current piece. Then we want to check to see if there's a win. So let's make a helper method. Okay, our isWin method. We have the horizontal that we have to check. Horizontal, vertical, diagonals. Okay. All right, so the first one, the horizontal, for int. Okay, let me say what I'm going to do here. After programming a while, some of these things you just think about them real quick. But no matter let's design it out before we do that. So let's see, we're doing the horizontal. So let's look at this. So what I mean is I'm checking here, here, and here. So what if, for doing that, what if I just have one loop that goes over the rows, like this row here? And I'll just check to see if the piece at this location is equal to the piece at this location. And if it's equal to the piece at this location. And if it's not empty. So let's look at this. X, X, X. So looking at this piece, is that piece equal to this piece? Is this piece equal to that piece? And is this piece not empty? If that's the case, then it's a win. If we know it's a win, we can just return true right away. Found it. Okay, if it's not a win, we go to the next row and we repeat the same logic. And then we go to the next row and we repeat the same logic. So let's go back and program that up. Okay, so we're going to say for row equals 0, row less than board.length, row plus plus. And then we're going to check to see if the board at the row and then this column, which is 0, column 0, remember, check it and see if that one equals the board at the row, column 1, and we'll check to see if, I guess I'll keep it on the same line for now here. The board on this row at column 0 equals the board at this row at column 2. Okay, last check here, and if the board is not null, or not, excuse me, if the board at location 0 is not empty. Board, oops, row 0 dot equals empty. Okay. Okay, so yeah, so this one right here, I only have to check location 0 to see if it's empty because I'm checking 0 against all the other positions. Let's revisit that. So I'm checking this piece against, let's say it was empty for a second. Let's say one of them was empty. Say this one's empty. Okay, so then this would be false, right? And then that whole if statement would be false. So we can just check this one to see if this one equals that one, if this one equals that one, and if this one is not empty. And if that's the case, then if all those are true, then there's a win. If it's not true, then it's not a win. Okay, so if that's true, then it's a win. So return true. Okay, next one, vertical. All right, let's talk about the vertical. Okay, so vertical, same concept. Whoa, that's weird. Close that, open this back up. Go here. Are you kidding me? Oh, okay. All right, so vertical. Here we go. So we want to check this one. Okay, and then we're going to check that one, and we're going to check that one. We're going to use the same logic, and we're going to iterate. This time, we are iterating over the columns. Okay, so same thing, except instead of the rows, we're doing the columns. So what we can do then, when we take this here, this down here, now we're doing the columns. Here, I'm going to show you how to change something quick. So I highlight this, I say Alt-Shift-R, and this is called a refactor of that variable, and I can type in the new variable and it changes it in all the locations. Okay, location 0. Okay, then we got to switch these guys. Okay, so I'm just going to switch each one of these. So the column 0. And then I'm going to switch this one to 1 column. So let's do this a little quicker here. 0, 2, 0, column, column, column. Okay, so that would be the case if that's a win. Okay, next is diagonals. Let's go look at the diagonals. Diagonals are pretty simple. Okay. All right, so let's look at our board again. All right, diagonals, we want to look this way and we want to look that way. And that's it. Okay, so let's start with this as our key, our 0, 0 location. And we're going to check that 0, 0 location against this spot and then against that spot, and we'll check to see if it's empty. And then we'll do the same thing with the other side. Use this, check that, and then see if it's empty. Okay. All right, so here we go. So we are going to say if the board at location 0 dot equals the board at location 1, 1, and the board at location 0 dot equals the board at location 2, 2, and it's not empty. Let's see, auto added that for me. And it's not empty. Board at location 0, 0 dot equals empty. Then, if that's the case, turn true. Okay, now diagonal in the other direction. Control Alt down arrow key, and that will copy that line. Okay, so in the other direction, so that would be 2 here, and then that would be 2 here, and then that would be 2 here, and then, okay, so we got 0, 2, which is up top to the right. We check to see if that's equal to that. Then 0, 2, and we check to see if that's equal to 2. And 0, 2, check to see if it's empty, return true. If none of these were true, then it's false. Okay, so we have our is when. So right in here, we would say if is when, then we're gonna say go ahead and display the board, the winning. Nice to see that winning board, and then print out player current piece 1. Okay. And then is game over now equals true. And then we're going to have an else if is draw here. No need to check a draw if there was a win. Okay, so let's do the draw. Okay, for our draw, what we need to do is we need to go through the whole board, and we need to check to see if there's any empty pieces. And that's the first thing that we need to check, and then we're gonna have to check something else. So we'll go through the whole board here, and we'll check to see if there's any empty pieces. So we say if board at row column dot equals empty, then we're going to return false. Okay, if that's not the case, okay, so if that's not the case, we get down here where the cursor is, then all the pieces are filled up. Okay, now in our tree here, in our if statements, we are we wouldn't have called this draw method if there was a win, because of else if. But maybe we'll want to use this not in this fashion. Like, let's say somebody did something like this, that would not matter actually. Let's say somebody decided for whatever reason it's better to check to see if there's a draw first and then check to see if there's a win. Okay, well, we want the draw method to actually independently of any other code, actually check to see if it is a true draw. So having all the pieces filled up is not only the thing to check. You have to also check now that even if all the pieces are filled up, let's say you put down that last piece you put down could have been the winning piece. So let's check to make sure that there is no win. Okay, so if all the pieces are filled up, if there's no win, then it's a draw. Okay, so if it's a draw, then we want to print out to the user that it's a draw. So first let's display that board, and then we'll just say it's a draw. And then game over. Okay. If none of that happened, then it's the next player's turn. So let's say get next piece here. And what this is going to do is we're going to say current piece equals get next piece. Okay, so get next piece is going to be a simple method that is going to just say current piece, which we need to pass in here. And we'll just say current piece, if current piece equals X, then return O, else return X. All right. So we got that. Okay, and then let's think about this for a second. So they entered in their inputs. We got let's bring this up here. We display the board. They enter in their input. If it's a correct spot, we'll place that piece. Check to see if there's a win. If there's no win, we will print this. But the last, let's see, the display board has a print. Let's see, there's a print there. And then the last one is a ln. Okay, so then that would be like up here. Let's give it a little more space though. Let's give it one more space. So when you're down here, say system.out.print ln. Okay. Let's see. Let's take a look at this again. All right, and let's think through the cases really quick. I'm gonna do this really fast just to not take up too much of the video, but you should come up with like 4 different use cases. It seems like it usually comes up to 4 cases to do like edge cases, but when I say edge cases, you want to check your extremes. So you want to make sure someone's not trying to place a piece out here. You want to make sure someone's not trying to place an A in there. You want to make sure that you know, the wins work, the draws work, and yeah, and those would be some good edge case tests. So just scanning through this really quick. We get the row column, pass that over to set piece here. Set piece checks those extreme situations, and we had the try catch earlier for the letter, and so we place the piece. It's valid, and then we've already talked about the win pretty extensively. So looking at that, just double checking we didn't fat finger something. It looks good. That looks good. That looks good. Okay, and the draw, that looks good. Okay. All right, so let's play this. Let's play it out. All right. Okay, so we have this, and we'll say 1, 1. Look at that, there's that. We want to give it some more space. So let's add one more here. We'll just say, we could do it down, we could do it either up here, like this. Let's do it up here. Okay, so 1, 1. Okay, great. And then let's say 2, 2. Excellent. Okay, and then let's say row 3, column 1. And then let's say row 3, 3. And then let's say row 1, column 2, or sorry, row 2, column 1. Okay, we won, yay! Okay, so I'm gonna end the video here. I'll provide the link to the code. Please like and subscribe, and we'll be making some more videos like this. All right, if you have any videos you want me to make some programs and record it, leave a comment or message me. Better leave a comment because I'll see that faster. All right, I'll talk to you later. Bye.